How many colors are needed to talk on a cell phone? The four-color theorem is a mathematical theorem stating that any map can be colored with just four colors, so that any two countries sharing a common border have distinct colors. Can we apply this theorem, which might seem quite abstract, to real life? Professor Shahar Smordinsky from Ben-Gurion University found an interesting analogy to the four-color theorem in cellular networks. If two identical frequencies overlap, network interference occurs. Therefore, in order to prevent interference in areas covered by a number of antennas, each antenna is assigned a frequency of its own. However, this requires many frequencies, which leads to a waste of bandwidth and is costly. Can we find a better solution for the problem of interference other than allocating a distinct frequency for each antenna? Here, Professor Smordinsky enters the picture. He showed that the number of required frequencies depends logarithmically on the number of antennas, if we think of each frequency as a color and an antenna's broadcast range as a disk. The algorithm, called conflict-free coloring, has several steps. 1. We start with a set of disks. 2. From the four-color theorem, it follows that we can partition the disks into four temporary color groups, so that overlapping areas will contain at least two colors. 3. We identify the most common color, assign this color group a final color, and then remove all the disks in this group. 4. We then repeat this process with the remaining disks. The proposed algorithm is very efficient. For example, instead of 1,000 distinct frequencies for 1,000 antennas, we now need only 25 frequencies. It turns out that the idea of conflict-free coloring also works for radio frequency identification (RFID) networks. Think of a barcode that tags an object using radio waves instead of bars. The challenge here is to correctly schedule the activation of each RFID reader. Here too, we can efficiently allocate reading times using the algorithm that Professor Smordinsky developed. We've seen how it's possible to take an idea, as abstract as it might be, and use it to solve important problems in the real world.